Welcome everybody to Robot Builders Night Virtual for Tuesday, March 11th. We've got the usual agenda queue going, and then we'll go to open mic and share whatever anyone has discovered that might be interesting. First up, we've got, let's see, any DPRG news. DPRG news, I have booked Ford's Garage for the second quarterly gathering, robot power lunch, which will be on Sunday the 30th of March at noon. So everybody's welcome to that. And with that, let me hand off to Fernando. Fernando has something to share. Fernando, you're muted.
Hey, y'all.
Hey.
Sorry about that. So here's a little test chassis got built for our swerve. And then, so we just have a control hub with all the devices going into it, and then going to control it on my side. And I just want to show it running, since I don't think we've gone to show it actually driving under code at all.
Cool.
Ya está la carne.
Uh-oh, it froze.
Sorry about that. Hold on.
Oh. Awesome.
So the chassis is a little funky because all the omni wheels, they're on extrusions that are a little bit too close to the ground, so they'll keep digging into it, and then they're probably not all level, which is what causes the weird turning. And then the code is very experimental because it drives forwards, but there's no actual way to drive backwards. There's some kind of error in the actual writing of the code. But yeah, we at least get to see that this is the concept for it. So that's a good step forward.
Could you rotate the phone sideways, because the picture is sideways? There we go. So that's cool. So you've got one swerve drive wheel and then 3 omni wheels. Is that right?
Yes.
So you can't actually control what the heading of the chassis is, but you can control what direction it moves in. Is that correct?
Yes. So we just control which way the wheel faces, and then the chassis will move in that direction. But the actual orientation of the chassis is just up to how the omni wheels interact with the ground.
Right. Nice.
And then today, actually, I was just in our Robo Dojo or workspace cutting out new plates so that we can start making the second one. And then that way we can have a chassis with 2 swerve pods. So that way we can actually control the heading and the translation.
Nice.
Very cool.
Cool. I like it.
I think that's all for me.
Thank you for sharing that.
Good job.
Thank you.
That's neat. Only one wheel driving it.
Yeah. Very cool. Okay, David Ackley.
Yes.
You were in the queue, right?
No.
Was there
Hi, David.
Okay, I must have I wrote your name down, but I must have misheard. I guess Mike's in the queue.
Okay, so I was been working on my robot, and then
before you get started, Mike, we hold on. I'm sorry, but I forgot. We need to We need to acknowledge Fernando's gold star for
Yay!
for showing a robot driving. Well done, Fernando. Thank you.
Yeah, so that's the picture from this phone. I'm going to try to get my phone working too. Let's see. Oh, here it is. Oh, there it is. Ah, I thought I had my thought I had my speaker off and everything. Maybe that'll do it. Okay, so so I'm using my phone here so I can zoom in on stuff, and I'm going to share my I don't know. Oh, here it is. So that is my RViz,
Ooh.
and it's and the and so here's my setup here. So I have the green dot on RViz is the on my machine here. I have a bunch of sensors. I have 2 time-of-flight sensors here, and they're pointing at 45-degree angles, so they get a nice field of vision, continuous field of vision. And here's the other sensor, the other one on this side. And then this sensor here this sensor at the very front is turn off the laser. I'll just leave it out. But the sensor here is a single point time of flight. These are multiple 8x8s. So I got 4 8x8 sensors. I think I showed last month that I had the sort of the cone of vision on them, and so that they light up a really big space. And so you can see I'm using my laser to center it, to make sure it's centered. So the green dot on the RViz is the center laser, and then the red dots is the time of the multiple the other time of flight sensors. I'm only using one line out of them instead of a big grid, because that's all I really need to know is the one line that can detect the devices. So if I move it closer, you can see that they both move at about the same time. And then when I get real close, the side time of flight sensors don't detect the can anymore. And I did it on purpose so it doesn't notice it, because they're here, they're just going to be skimming it and they can't see it. When I pull it back a little bit, and they can start to see it. And so the idea is to use the time of flight sensors to be able to center the can when I get close, because the camera sort of is far-sighted and I can't see when the can gets close. So I can move this back and forth. And then once it's sort of towards this, like the center sensor has an 18-degree field of view. And
And the
Then-
green dot is the position of the robot. Is that correct?
Oh, the green dot is the single point
Oh,
time of flight sensor.
oh,
Yeah, the red dot on the very bottom is where the robot is.
oh, okay.
Yeah, it's just there by quote mistake. It's when some of the data points can't be seen or aren't good, then I map it down to 0. And a lot of times, especially in this setup here, a lot of the points don't have good enough data to be reliable, so it's mapped to 0. So the one on the very bottom is the where the robot is.
Okay.
The cannon got close, and then the red and green dots did it. Oh, that's my foot. Okay. Yeah. And then this here is the other can, so it gets moved around. And so I'm thinking, like, even my foot here, I'll put 2 feet in it. So I got 2 feet in the can, and so it can see the obstacles pretty well. So I'm really happy with that. I got it running and turned into a point cloud that I can feed into the navigator for obstacle detection. And I've built my robot, and it's mechanically complete right now. So you can see here I have the CPU board that ties here, and I have the power supply over here, and I have the power right here with the lighter on top, and here in the middle, and the very front is the camera. And then this device right here is the laser for pointing. So basically, it sets the center of everything, so I can calibrate stuff and etc. And back here is the controller board for the motors and the grippers and the limit switches. And this board up here is the sensor board. So you can see the wires coming off, going to each of the sensors. It also goes to the current sensor here, the center time of flight sensor, and the IMU. So all the sensors go on this board, and this board here does all of the kinetics, basically, except for the limit switches. Because I put the limit switches on that one so that it can stop closing the claw when the limit switch gets hit quickly on the CPU without having to go through a big ROS stack, because that's really slow and it was crushed, it just doesn't work that well. So I did have a way to activate the claws. If I look at the bottom of the machine, you can see I have the claws.
On a servo.
Yeah, each of them has their own server. And then there's the power supply for the battery and the caster wheel, and then of course the 2 wheels on their motors. So the claws are just really simple paddles. And the top of it has the limit switches. So when it grabs its hand and the claws push it into the limit switches, when they click, it stops pushing. So
Hey, Mike, back on those side fate or the diagonal side one time of flight, did you say they were 8x8 or 8x1?
They're 8x8. They're the BL53 L4 or L5, I mean. And
So
but I'm only using one row.
that's what I was wondering. Okay.
because I'm just looking for a line. Actually, I'm using two center rows since there's no actual center, and I'm sort of averaging them together to get a more reliable center line.
Yeah, that's what I was wondering, because they're going to have their own divergence in cone pattern, right? Vertical cone pattern.
What do you mean?
The 8x8, it leaves a very small aperture there at the end of the sensor, and then I presume that it kind of just diverges in some kind of cone at some angle, whether it's a XY angle or a up down.
It's a 45-degree field of view on each sensor,
Okay.
and it's split up into 8x8, 45 vertical and 45 horizontal. So it's basically a square field of view.
But a cone that keeps getting bigger and bigger at 45-degree.
Right.
Okay. So the question I had for you, and it sounds like you've done something like this already with the two middle-ish out of the 8 vertically rows, but it seems like there could be some benefit to because of the 45-degree up and down cone angle, that you might have an ability to detect taller or shorter objects instead of just a relatively narrow slice down the middle.
Yeah, they could do that. Yeah.
Hmm.
The lower ones hit the floor really soon and they're not very useful, but the upper ones could detect a rough measurement or something higher and lower.
But the lower ones could, I presume, detect things that are closer in.
If they're short, yeah.
Yeah.
Like the can, basically they're set to be in the middle of the can.
Right.
And so for the 6 can, I'm just using one row. But if I was doing sort of obstacle detection for outdoors or just general room environment,
General purpose. Yeah. Right. Okay.
I'd use more, like up and down,
That makes sense.
to see if there's a chair or a rung or something that I got to avoid.
Thank you. That explains.
And then the center sensor right there is a VL53L4, which has an 18-degree field of view but only one sensor. So it's supposed to be a pretty good sensor. So, so I'm pretty excited about my sensors and my build and everything. I'm gonna shut this thing off.
Looks good. Looks clean.
Yeah. So, Mike, have you tried navigating using the Nav2 stack yet?
No, no.
Just curious.
Yeah, that's I'm doing the fun part. Building the robot is fun, and programming the microcontrollers is fun. But the getting into the nav stack I don't think it's going to be very fun. but I'm using right now. I'm just using ROS just for its tool set.
Yeah. For
communication.
Yeah.
And
so
sure. Yeah.
Thank you.
But now that I've got everything basically working, and hardware wise, and the interfaces to the ROS, that like I don't know if you noticed on there, but there's the USB cables. I'll bring the machine to this camera. Like the oops, see if I can do this. Like the USB cables here, they're hooking up. Like this one goes from the let's see, the microcontroller here comes out of a USB-C connector and then goes into the USB here on the Pi. For the camera for the camera, well, let's go this way, I guess. For the camera and the LiDAR, I'm plugging them into into this USB hub that's sort of buried in there. Let's see. So, trying to get a good picture of it. How do I get a good picture of it? Yeah, it's pretty buried in there. But there's a USB hub that's powered from the power supply, and so it doesn't grab the power from the Pi board. And on each of my microcontrollers, like if I can show a microcontroller here, it's hard doing this. Okay, so on this microcontroller right here, this is a power supply wire. So I'm running power from the power supply to this, so it doesn't use the power from the Pi also. So I'm not really using the Pi to power anything except for itself. That's a safer route design technique.
Nice.
Yeah.
Cool.
That's my show and tell. Hardware's done. Microcontrollers are done. I might be tweaking microcontrollers, and might be tweaking the hardware just a little bit because those two side sensors, they overlap, and I'm trying to calibrate it so that they when they both see the same object, it shows it in RViz at the same point. So they have to, be calibrated pretty well. And so I don't want to have double vision, like something here and something there. So, and it's working pretty good. I was sort of testing it and going, hey, this is cool. Yeah. But round objects like cans sort of give the time of flight sensors a bit of problem because of the reflectivity. If I put a square object like a box, they agree a lot, but with round cans, they start disagreeing by tens of centimeters and stuff. So, or tens of millimeters, I guess, 20 or 30 millimeters. Yeah.
Okay.
All right. Well, so hopefully I'll work on Robbie some more because
Cool.
I got distracted with this because it's fun to get its head ready and then start doing more software. Like I want to put the LiDAR in there because that's not really software development. That's just grabbing someone's code and making it work in my code, and then put it on RViz. And then I got to study real hard how to get navigation stack working. Yeah.
Nice.
Okay. Thanks.
Thanks, Mike. Well, I'm going to jump in behind you because I've got kind of like a related show and tell. So this is Minniebot, and I got this claw. It's rather heavy and rather big, rather larger than it really needs to be. But it's powered by a servo that's tucked in behind it there, and I hacked the connector on the general driver for robots here to where I had to rip the sides off the connector so that I could plug the servo connector from the claw in, but then I was able to just import the ESP32 servo module and get it running on the ESP32. So that's quite pleasing. So it's not under ROS control yet. It's just sitting there running a test program that cycles the servo through the full range of motion. But anyway, such as it is, that's what I got.
Yeah, I wish I could have had my claw open and close. I had it earlier, but it's a really complicated ROS command, and I had and I didn't really No. Yeah, I did. I didn't want to type it in because it's like that long, the command.
Yeah.
From the command line, that is. Yeah. That's great.
Pretty good.
All right. Well, that's all we had in the queue. So unless someone else has got something, let's move on to open mic.
Well, I've got what I've been working on. I can show and then sort of ask if anyone's got an idea on where
Yeah.
I'm going wrong. Basically, this is long enough. I don't know if you guys can see that.
Yep.
There's my practice arena.
I like it. The box. That's great.
It's a box with a can. So basically, got the box, the can, and if I share my other screen, share, is that big enough for you guys? I really reduced the resolution on the Pi to try to get it to show up. I'm basically running a, oops, I lost my window. Go back to that one. Basically running a Python program that grabs the LiDAR image, and it does a fairly good job of grabbing the LiDAR image. So the robot is back here somewhere. There's the can. And you can see as I get closer to the corner, my back corners aren't too bad, but my front corners tend to fade out, and that's probably because the box isn't quite square. So I'm in the process of trying to detect the can in here, so at least I can detect a can. But the problem I have is, so when I turn the robot, my image shifts, but it doesn't clear all my pixels. So you can see a lot of artifacts left over from when things shifted. And can I get out of here? And how do I get back to regular mode? I don't know.
I know in RViz there's a memory, a history memory. So I guess this program has similar.
Yeah, so I'm going to close out my connection here and re-go back into it because it's doing weird things on me.
I wonder if it's not getting valid readings for some of the points and it's just using old locations.
Well, yeah, I'm trying to figure out how the heck do I get out of my Raspberry Pi display here. Full screen. I don't want full screen. Okay. There, finally. What a pain in the butt. Okay, go back to sharing my screen. So there is my screen. There is my Python program. A little more readable.
Mm-hmm.
Sorry, I'm just in text for now, but basically create a Pygame display. 320 by, or 300 by 240. And I don't know why I'm 300, but anyways. So basically, as I process my data, I fill LCD, which is my screen that I'm displaying, with a white. So the whole thing should overwrite with white. Then I read my LiDAR data and process my XY coordinates out of my LiDAR and calculate my points and set the points in the game with the color black. And then when you call a display flip, that should take everything that's in memory in LCD and write it to the basically the screen, the window. And that's why I don't understand why I'm not clearing that out. So at the beginning, I clear it out before I do anything. And I overwrite it. Well, on my next scan, I would think that I would clear it out, eventually just erasing all of the artifacts as they go on. It's just not working for me. So where I'm going with this is to try to get an image that I can process in OpenCV.
Can you move the fill just above the LCD set point? So yeah, like right there.
No, if I do that, so I don't know if I can make this a little better so it's not wrapped around.
Yeah.
So if I move my LCD fill, you're talking about this guy?
Yeah.
Yeah, so if I take him and I put him, you're talking about putting him in
Yeah.
here.
Yeah.
So what that would effectively do is create a white screen just before I write a pixel to the screen.
Yep.
So I would erase all of the screen every time I wrote a pixel.
Oh, you would. Yeah. Okay.
So
Hmm.
so right after your for loop, if you do an LCD fill, does it wipe out everything?
So if I do an LCD fill right after this guy, it should wipe out this
Yeah.
LCD that I wrote all my points to.
After the for loop, that one time before you do the flip. I was
Yeah,
just
so-
wondering, does it really
I've also-
fill it up?
Yeah, so if I do it as a test,
Yeah, right.
so if I put it in here just before I do my flip, and go into here because Pygame doesn't like displaying on a window until they tell it what display to go to.
Mm.
So now I've got a white window.
Hmm.
So I'm overwriting with a white window.
Huh.
That's weird.
So if I take this guy, so get him back out of there, and I put him in right there before I call, hey, so wipe out your LCD before you go process your scan data. And go back into here. So I end up, I know that's a little small for you guys to see,
Okay.
but again, as soon as I move my robot, I don't know if you guys can see that, but
Yeah.
I've got artifacts everywhere.
Yeah, we
So,
saw it stay. Can you scan up higher in the code again?
Yep.
So where does Pygame get reinitialized at each iteration?
Pygame starts at the beginning of the program where I initiate Pygame once, and then I set my LCD, which is the screen that I'm running. That's the LCD is the screen that I'm going to display, just the display.
Yeah,
I fill the display window with white. I do that once.
right.
Blank off. I set up my LiDAR stuff.
So I got an idea for you. Right there below global max distance,
Yep.
instead of lcd.fill, why don't you do pygame.init?
Well, because that would initiate Pygame every time I ran the loop.
But I think, so if you go back up higher, because it looks like to me what's happening is that the fill is doing what it's supposed to do. And the reason you're having artifacts is because they're hanging around still in Pygame. So it seems to me that you need to reinitialize that pygame.display. Well,
This
yeah,
guy.
so somehow, so that's where the data is getting hung. That's where the data is sitting around in, right? Wherever Pygame is storing.
Yeah. So what I did before was I took this guy and I put him in here. So I had LCD as a global. which should resolve that issue.
Why would it do that?
Some
And it's not a very complicated program.
Why are you calling Pygame.display.flip instead of LCD.display.flip?
Because Pygame is the display. It's an actual window that you're displaying, whereas LCD is tied to Pygame display
set mode.
set mode.
Okay, I got you.
but
And all the examples are doing it the same way.
Mm-hmm.
So they were using Pygame update, which I've tried unsuccessfully, and most of them are saying write everything to your screen and then do a flip. So the flip should take whatever's in the display memory and set it to this guy instead.
Yeah.
yeah,
I'm sort of scratching my head as to why. So the reason I did that is because if I go back to this guy, cancel out of here.
Do you mind sharing the code file, Pat?
Yeah, like is it up on GitHub where we
No,
could,
it's not up on GitHub. So I haven't created anything for it yet. I'm not far enough along to even contemplate it. I don't mind sharing the code. I can post it to the
Discord.
to the group,
Yeah.
to Discord or something.
Yeah.
Do I need to put code blocks around it to share it?
what is the difference between the LCD object and the Pygame object?
Pygame object is the background process, I believe, for displaying the window. And LCD is essentially, as the mode suggests, create a Pygame display with a mode of that size, 300 by 240.
Right, but again, so LCD is something that's returned by display.set mode. And
Yeah,
apparently you do a fill on
LCD
it.
is a graphic type image in memory.
it's an instance of a Pygame display.
Yeah, in the memory. So, and I know it works. I'm able, when I fill it, I create it, it's created in black. I fill it, it becomes white. I fill it, it becomes white. And then when we go to display it, do the flip, then it turns to white.
What-
So
What,
if I run it, you can see that happening where it'll create a black window. It flips it over to white and displays my LiDAR data.
Yeah,
And
if you move your robot, then some of the pixels persist, right?
yeah, so when I'm looking on, and it's probably really hard for you guys to see, I can see pixels turning on and off here
Yeah, yeah.
on the line.
We see
And
them.
so,
Yeah,
so
we can see 'em.
it's not like they're persistent. They're coming on and they're going off and they're being replaced by white.
yeah, right.
you know?
But when you move it, you're saying something persists.
When I move it, you can see
Oh.
here.
The ones at the end. That's the thing that gets me is that
Oh.
it's so weird. It's like they seem to be at the end.
Here's
So-
where my hand was.
What
You
if
know,
you
it-
move it again? What does?
Okay, I'll put it back where it was. So I moved it back again.
Makes a mess.
Yeah.
Yeah. And it's, to me, like the LCD set, it should be overwriting all of that memory with the white. When every
It seems
time
to
I
be-
call the routine, it
seems-
should be wiping it.
Seems to be related to those gaps where you said your box is not square. So it seems like where those gaps are, that's where the pixels sort of persist when you move it.
Yeah, it sort of does.
So I don't know what that means, but it's something.
Can you show the code again to what's behind the graphic?
So
And
the-
actually, should you be flipping? Should
Yeah.
you do pygame.display.flip or lcd.flip?
it should be Pygame display.flip. So Pygame display takes the window that's being displayed and flip it with what's in LCD memory.
If you stick your hand where the artifacts are, do they go away?
I never tried that.
That's a good idea.
I wonder if it's like a weird reflection off the can or something.
Maybe you need to try a bigger box.
So
Yeah.
there's my hand. I put my
Yeah.
hand in and I removed my hand.
Ooh, and it stayed.
Wow.
There's the other side.
Persistence of vision.
There's the back.
Oh wow. Hey, it's what someone observed, that it's in the angle where there's no box showing that the persistence is happening.
Yeah.
Yeah.
So
Wow, look at that.
Yeah, that is weird.
so I find that strange that along that angle ray where it's looking at, it's
Oh well, look, when in your code you're going through for angle in the range of 360, you look at the distance, and if the distance is greater than 0, then you calculate what X and Y should be written to. But apparently you've got some gaps in your data where the LiDAR is not spitting out ranges, not spitting out distances in two angular segments.
I in some segments it's not seeing
It's
the
not
box.
in the box, and so when you put your hand there, it records the hand, and then when you take your hand away, there's nothing coming back from the LiDAR in those sectors, and it's retaining, because there's nothing coming out from the LiDAR on that range. It's retaining what's there.
Yeah. So
So like the LiDAR's memory is persisting.
it's, I know, but that's the LiDAR shouldn't have memory persisting. It's just read it and spit out the serial values.
Yeah.
Right.
So,
Yeah.
so let's trace the data from the LiDAR output into this function.
There's another easy solution. Don't use a square box. Use a rounded, areas.
Ray, always got a wisecrack.
Find a straighter box. Yes.
Right.
So where does the LiDAR update occur? I mean, do you need to clear the output buffer of the LiDAR sensor, for example, before
So
every reading?
my LiDAR happens here. So scan data.
So have you had a look at the actual raw LiDAR data?
So
Because some
so
of the LiDARs will output NAN, not a number, or -1 or other invalid values if they don't get what they consider a decent reflection.
yes, but could be it's NAN.
Yeah, I think the older Nito
Even if
LiDARs used to.
it's not a number, because this guy wipes everything out. Make it all white.
Well, that wipes out the LCD, but not the data.
If my distance is greater than 0,
So go back down and show your
But if
LiDAR.
distance is NAN, because that was the data that came out at that angle from the LiDAR sensor.
so I could look at if it's not NAN and it is greater than 0.
Mm-hmm.
Process the LiDAR point.
Mm-hmm.
Yeah, I know the older Nito LiDARs used to have like a signal strength or signal quality,
Yes.
variable, I guess. And
There
I
is
don't know
there
what
is
these
a
have though.
signal, there is a signal quality in here as well.
Yeah.
So there's angle, distance, and signal quality coming back.
But I have seen NAN come out as a range out of my LD19 LiDAR.
Ooh. Damn.
So in your LiDAR loop, how is the data array configured or created?
How is the data array created?
Where you
Created
read the radar and
in the
populate
LiDAR
the
loop.
data
It is part of the routine, basically, that I got LiDAR.
right there.
So it's part of the Python library for the RP LiDAR.
So can you walk us through that? So for each scan, does that mean for every complete 360 scan?
For every complete 360 scan,
Okay.
okay, it goes through this. So for basically, get info just gets the help of the LiDAR. And then for scans in LiDAR inner scan, so it'll go through and do a complete scan, 360 degrees.
Okay.
And out of that 360 degrees, it returns basically an array with angle, distance, and quality.
Can you pre-fill the scan data with 360 zeros?
Yeah. Yeah. Before that for loop.
Oh, before the for loop.
Well,
just-
is the first line. Yeah.
Oh,
Oh,
no,
yeah,
in
another
the, in the
Clear
scan,
out your
in
matrix.
the LiDAR scan. Is okay.
So
So,
this
so it's
guy-
initialized.
Exactly. Exactly that.
So we take this guy and we take him and put him, get our LiDAR health.
That's it.
Okay, and we're gonna make that equal to 0.
I bet the team just nailed it for you.
So if we set all the data points to 0,
That'll only set one data point to 0, won't it?
Yeah.
no, I believe that'll set all 360 to 0. Because I have point 0 to 359. Right?
Yeah.
I create
That's
LiDAR
different.
data.
That's 0 in parentheses times 360, which means take that angle bracket. I
Take
think
this
that
and make 360 of them.
360 times.
Yeah.
That's 360 instances of 0, which is different than what you just typed.
That's different
Yeah.
than this.
Yeah, Python.
So
Just type the exact same line.
so you want me to recreate this guy?
Right. Instead of using the global variable. I thought it was
Times, times 360.
But it's not recreating it, right? It's just assigning new values, isn't it?
I'm not
There you
sure.
go.
Let's find out anyway.
There you go. Boy, whoever caught that, that's teamwork right there.
That's why I have you guys in my back pocket.
Dump the cob.
Phone a friend.
Is that can very reflective? Does it have tape on it?
It's still there.
Oh man, it was such a good shot.
That can has just orange tape on it.
Oh, okay.
but-
Do you have something else that's like not as reflective, maybe, and not round but square or rectangular?
No, we only have circles in my house.
Okay, that's a problem.
But I think it's something persisting in that scan data array somehow.
So there is a non-circular object in there.
Okay, good. Humor me.
So now you can see a flat edge.
Yep. Okay. Give your robot a twist. Yep, still there.
Yep.
Okay.
Yeah, so interesting.
Why did now there's a bit to the left of the robot that is blank.
To the left of the robot. You mean over here?
Yep.
Left. Over here.
Lower left of the image, there's a hole in the wall.
That's where my hand was. I restart it so we can get a clean image.
Okay, so there are two missing series of
Yeah.
data points here.
Yeah.
One forward and to the left, one forward and to the right, and one about horizontally.
Well,
at
the
90.
robot is facing towards the right.
Yeah, and right. So to the robot's right. So at the bottom left of that rectangle, why is there a big hole there?
Because my box, I'm closer to that side of the box. I'm closer to the bottom with the robot than I am to the.
Probably
the
the
middle.
angle's just too shallow
And
against the wall.
the whole
And you
box
don't get a reading off it.
is maybe 20 inches wide.
Yeah.
I bet you're getting not a number. You should just look at the data, just like print out a scan's worth and see what it looks like.
Yeah. So how do I print out a scan? I've been trying to do that.
So is that just an ASCII NAN?
Yeah. NAN.
NAN is a special value of a float or a double, depending on what they're using.
Oh, okay.
So this
And-
did nothing for us. But this guy here, so if my distance not equals is oops, not equal to
No, it's not that. That's a quote. NAN is a special.
any a value, yes. Is it
it's
in
a special
capitals?
value. I don't know how to write it in Python.
I think it's a lower A.
Yeah.
You think?
NAN is not a value.
Yeah,
Right.
not a. You think it's lowercase, not a number?
Just the A.
Oh, just the A.
Yeah.
So it's not NAN, and it's greater than 0.
You missed out some logic there. I think you intended to have two operations there: distance not equal to NAN and
Distance
not
not equal to
greater
0.
than
Or
0.
greater than 0, yeah.
And
Oh, it's Python. It's the letters AND.
Yeah.
I thought AND was
Yeah.
Boolean.
Yeah. And distance.
If distance is not equal to NAN and
Distance, yeah.
Mhm.
Greater than.
greater than 0.
Uh-oh.
NAN is not defined.
Okay. How do we express NAN in Python?
It's NAN value is here. I got something from Perplexity for that. Unless you have NumPy or something, I'll put it in chat.
Okay.
Just a second.
I will have NumPy, but not right now.
There you go. Try that.
Oh, you can create it. Oh, let's see what did that do? Yeah, float NAN. That's what I found too.
Okay.
So we've got NAN written there. You should write float and then in parentheses NAN in quotes like Carl wrote.
Yeah, so that's what I did. Just copied it. And then we're going to make this.
NAN underscore value. Yeah.
Oh, yeah.
What will?
Oh, get health. No, I'm still spinning. Okay. It didn't shut down properly. Okay, here goes again.
Different.
But that's better.
This is dastardly. This is absolutely dastardly.
Well, I still think you should put a for angle in range 360 print angle, and print will, if you do print angle, it'll print NAN if it's an NAN.
Okay.
And I
So
was thinking you should.
Well,
so
print
that didn't do anything.
I don't know.
Well, so is it, and maybe what Paul's suggesting is another way to answer this question, but is it possible that this LiDAR returns the last scan distance if it can't see any distance? Or if the distance it sees is out of range?
It's an RP LiDAR. I would think not. And some of the values are outside of the box wall. But anyway, so let me get this back. So if distance is greater than 0, for angle and distance, and we're just going to print the distance?
Yeah.
Or do you want to print the angle?
Print the distance.
You're just going to look for things that aren't numbers
Right.
as they stream by in this
Right.
tiny font.
In the ether, yeah.
Yeah.
Oops.
Yeah. Hopefully you can scroll back.
I think you should make the windows smaller.
I think he's being facetious. Yeah.
Okay, so now quit your program and scroll back and look for funny numbers.
Funny numbers like 370 millimeters. I was gonna say that's not degrees.
No nans in the bunch. Huh?
Nope. Okay, so much for
But
that.
When you're processing the LiDAR data, don't you do an if statement there too?
I'm not seeing for
I've never
however,
actually done it with LiDARs. I wonder if you looked at it with your phone, if the phone camera could see a bunch of weird reflections off of things. Maybe.
But I thought when you're scanning the LiDAR, I thought there was an if statement when you're putting the data into the data array.
Yeah.
when I'm scanning,
It's greater than 0.
so it's just for angle and
Oh,
scan.
okay. Okay, so there's no if.
What
in
is
there.
it? There's a
No.
min.
There's a min 359 or floor angle.
Take the smaller of those two. Or what? What does that line do? I'm so half asleep.
Distance.
For blank, comma, angle, comma, distance in scan. So
Okay.
So it's writing.
so the minimum of 359 or floor angle.
So angle's a float, I guess. Yeah.
I was looking to it. What is floor?
Floor is like a round.
But that's
Round down.
So
that's the index to the. that's
I
the
don't get
index-
what this is. I don't get what that is. So for blank,
No.
angle, so it's an underscore, angle, and distance in
I guess
scan.
it's ignoring the first thing in the
Oh,
tuple.
Ignore the quality.
Yeah.
So quality, angle, and distance. So in the scan data, take the minimum of 359.
An angle must be a floating point. So you're rounding it to an integer.
So floor of angle takes it to an integer.
Yeah, okay, that makes sense.
Okay, but all right. So what gets me is that are you guaranteed to have 0 to 359 entries written into that scan data array? I mean,
I
so
should have an angle for every
angle.
I should have a measurement for every angle. But there may be more than one measurement for an angle. So like it might be 300.1 degrees and 300.8 degrees.
Oh, so it's not.
There should be like 2,000 scan points or something like that per.
Up to 2,000 scan points.
So you have about 6 points per angle per degree or something. Yeah.
Oh, so this will just take, instead of trying to average those points, it'll map this to
the last one. Yeah.
The last one for that angle.
But are we, and I guess when you had the other line that's now commented out, the initialization scan data is equals array 0 times 360. That showed that it's not from missing an angle. You got it initialized somehow.
Yeah.
So, and then you did the print in here, and we watched. No, we didn't. We watched the print. Okay, we watched the print distance at the other function. We didn't try the print. What is every value coming off of the LiDAR from here?
Yeah.
So we need to scroll through what is the value coming off the LiDAR, because it seems like this is where your problem's coming in.
Right, and print the angle and the distance both.
Can I print 2 in 1 print statement?
Yeah.
With the space do you need, or does it automatically?
I don't know.
Comma introduces a space.
Nice. Okay.
Without formatting it into anything, but
I'm just seeing angles there. I'm not seeing distances.
yeah. Get rid of this guy.
On a separate print.
Yeah, I don't want to do that, but
Nice. Yes. And then distance too.
One of the things I wish I learned to do was type. After that, it was program. Okay, so we got some values coming back. Give it a twist.
Yeah. Let's look for. I do see multiple values for each degree.
Yeah. So 100. So here's one. So angle 123.75. My next angle is 125.
Ah,
So I'm missing 124.
yep.
Okay, I got 129, 131.
There you are. But those were initialized to 0.
Yeah, so what I don't understand is they're initialized to 0. We don't wipe them out between reads.
So they retain their value.
Well, when we did this, we wiped them out, put them to 0.
That's, yeah, right.
So we set them to 0.
Hmm.
We created scan data. We wiped out our LCD. Hey, fill it full of white spaces. So get rid of all those artifacts. And then we go process our scan data.
Hmm.
When we process our scan data, we again wipe out the LCD. And then we take our, for angle and range, 360, we go through our data. So it's going to go through all the it's going to go through all of the scan data.
That's available.
Yeah. So we send scan data, it's here. So we go through there, all through 360 points.
Okay. So here, okay. So so if you go back down to where it reads the LiDAR.
Yep.
From what we just saw of the print, everything like this, you're winding up with angles that are missing data. So what I think you need to do is you need to get rid of this monkey business that, well, I think you need to have you need to generate an array that has, well, I guess 0 to 359 would be the index. Okay, so it doesn't need to have a separate index because it's all relative. But okay, now I'm rambling on you. So let's say take the example you had before where it jumped from 123 to 125.
Yeah.
On the degrees. So that would mean in this, that would mean that it would put a distance for 123 and it would put a distance for 125, but it would not put a distance in for the index, the scan data at 124.
Yeah, so it means that this guy came back with no data for 124.
Right. But
because
if you leave the initialization line up above, that should mean that 124 should have a value of 0. Right there on above the for loop.
Yeah, it should. 125 should have a value of 0. Then in here, if the distance is greater than 0, do this. So
it won't write any 0 values.
Yeah. So if it's 0, what happens to all the math if we're 0? It's going to screw it all up.
Nothing. It leaves, well,
But I mean, if we iterated through every one, even if the distance is 0.
No, because if the distance is 0, then you're not going to compute X and Y.
Yeah, we still won't compute X and Y, yeah.
So X and Y will stay at whatever their...
We don't reset X and Y.
Well, they won't get written to LCD at that point.
No, but then they'll get overwritten on the next one. So X and Y would stay at the last value. X and Y aren't defined, so are they redefined in here? It's just overwritten every time we get there.
But
because the only place we use it is in this loop.
Is to define the point.
Is to define the point. So it doesn't matter what they were, they're going to get overwritten if we're putting a value into if we're going to write a bit or a pixel.
So you won't execute the set at point method. So whatever was in that location will stay in that location.
So so when we go for angle in range, so it's going to go through this whole thing. So it's 360. So we get to 124, and 124 doesn't exist. Well, it does exist. The angle is 0. We initialized it to 0.
Right.
So it's going to say if the distance is greater than 0, it's not.
It doesn't execute that. So therefore, it doesn't execute lcd.setAtPoint. So it never changes whatever value was at that point in LCD.
Well, it did up here. It did up here.
Yeah, it's initialized to white before that. It's only set to black in that if distance greater than 0.
Yeah.
Yeah.
So to me, that should wipe out all of our artifacts. That we're getting in wherever it was. I don't have a picture of it, so. So that's been today's problem. So before that, I was working on matplotlib, and matplotlib works. Let me just do it here. Matplotlib works. New plot. Is it new plot? So here's matplotlib.
Nice.
With that same scenario.
Nice.
And I move it. And it should have moved. I didn't see it, but
yeah.
So I moved it again. So 5 seconds, 10 seconds.
That moved as it did move. Oh.
20 seconds later, it moves.
Huh.
So that's my problem with matplotlib. It's just extremely slow.
But it doesn't have that persistence.
But
no artifacts, yeah.
It doesn't have the persistence. And I think I have to reset my LiDAR. Yeah. Because it doesn't stop it. So it's the one thing I did was I got rid of my dongle, USB dongle, because I said, oh, okay, I can control the speed of the motor. And which you can't do with the USB dongle. Only to find out that at 5 volts, it was at 100% anyway.
Hey, guys, we spent a lot of time trying to debug this, and we've got a visitor in the group. Sunrut is a First Robotics FRC competitor. So I'd like to ask him to introduce himself and give us some background on what he's up to. But the bottom line is that his dad contacted DPRG through the Facebook account, saying, "Hey, can we advise on a hardware problem or some kind of technical problem that Sunrut's team has?" So he's running short on time. He's got about another 10 minutes. So if you guys don't mind, I'd like to interject him at this point, and let's understand another stump the club problem, and understand if there's some way that we can help. So, Sunrut, do you want to tell us about the situation where you're in First Robotics, but you don't have a mentor, or and what is the actual issue you're facing?
Hello, everyone. So since last week, the issue we had was our robot that we were making for the competition. We had a wiring issue where our CAN bus, we weren't able to, basically what was going on is some of our CAN bus, we weren't getting proper signal. And our power distribution hub, it was telling us that we were getting an overcurrent error. Now, since then, we solved that issue because we realized that our Wago connections, we had rubber touching the metal, and when we adjusted it, it fixed the issue. But something I'm worried about for the upcoming competition, which we have another competition in Amarillo from March 27th to 29th, is that since we don't have a mentor, one problem that we're having is troubleshooting wiring issues. And we were wondering whether you would have a specific process that we should go about whenever we don't have a mentor or someone to go to, because we're entirely student-led.
Kareem, are you on the line here?
I am, but I sure don't consider myself an electrical engineer.
No, but I think this is a sort of a higher level question. So Sunrut is in FRC, which you're in FTC, so different leagues.
Yep.
But I was surprised to hear that there's no mentor, and don't know if you know any of the hardware that they use in FRC, or how you would go about chasing down wiring problems.
They do have different hardware. They still have a Java-based development environment for most part. I assume that's what they're using.
Yes.
Yeah. Definitely a different controller. Different limits on the amount of power that they can draw. They can draw much more power. They got bigger batteries and all of that kind of stuff. So, but just like any robot, you got to get your wiring right. And so I don't know that I have specific advice to give other than doing real work to diagram what you think the wiring should be, first of all, and then if from a logical standpoint, and then confirming that that's the way the wiring is actually going. The kinds of errors that I see include things like getting, it's less around getting the polarity wrong on power, because that tends to be immediately revealing or cause big issues. But I do see signal lines being crossed and not being double checked very well. The thing with the Wago connectors is kind of interesting, because normally you'll have a low current thing when you've got insulation in the way, but if you just have way too much insulation stripped off, then you can get shorts to ground and things like that. So it's just a matter of being really precise. I would say that for my teams, wiring is one of the top issues in just taking the amount of time required to make sure everything goes neatly where it needs to go, that it cannot be snagged by movement of the robot and the subsystems, that kind of stuff. Because when so strain relief on the wires. You know what that is, I assume?
Yes.
Right. Yeah. So that's a really big thing. To make sure that the mechanism can't strain the wires. But yeah, you just need to make sure that you've got a wiring diagram that is accurate and can serve as a blueprint so that other people can double check your work. Individuals will make different mistakes around sort of what they overlook. And sometimes it's good to bring a new pair of eyes to double check the work.
Okay. All right. Speaking of like the wire strain, I just had a question pop up. This could be useful for later, especially. We have an elevator mechanism on our robot currently, and one problem we've been facing a lot is getting the wiring right for the elevator, especially since the wires move as the elevator extends upwards.
Yep.
And one thing we're doing currently was we had a cable carrier that's looped around the elevator, but the problem is the extra wire that we have, it's kind of just clumped around the bottom center of the robot. So you're wondering, do you have any better ways to manage wiring with an elevator mechanism?
Yeah, it depends a lot on the amount of current that you have to deliver. This is a thing that all FRC and FTC teams tend to struggle with. I've seen a lot of different solutions from physically jointed mechanisms that you attach the wires to, and that they constrain the motion of the wire. A flexible cable tray. I'm forgetting the actual normal name that we use for those, but like the kind that you have on a CNC machine, that will have links in it, and then the cable runs through it. That's usually a really good approach when you have very constrained motion, like along a linear slide or something like that. If you're also doing rotation at the same time as you're doing a linear slide, it can get a little bit more complicated. My teams like to use those curly multi-strand cables, but they're not going to deliver a lot of current for like a big motor. Hopefully you've got your main motors lower down.
Yes.
Yeah, so you're not really trying to deliver a lot of current up high. Is it mostly sensors you need to reach? Maybe
yes. So a lot of our motor, I mean, we have like a few motors on the elevator, but most of our primary motors that move the elevator at the bottom of it and aren't moving.
Yeah.
But one problem we have is the signal wire, CAN bus wire. It disconnects really easily because it gets strained on some extra part that we may not have noticed.
Right. So CAN bus should be able to go through like a multi-strand coiled cable. We use cables that we get off of Amazon. They're typically sold for microphone extensions or radio handset extensions, and you might get up to eight wires going through a coiled cable. And the coil really helps constrain the motion, but still give you a lot of the extension capability. I've seen teams use scissor lift mechanisms as a way to constrain where the wires go, so they all end up folded up. But in all of these cases, you're not really lengthening the amount of conductor that you have. You're just making sure it folds nicely when it's all retracted down, but can give you the reach that you need.
Okay. All right.
But yeah, we'd have to see like actual photos and stuff like that of your robot to give more guidance, probably.
I have a basic question. Is does the robot work a lot of the times, but it's intermittent, or is it just something just doesn't work, period?
Period. It sometimes works, it sometimes doesn't. We recently took it to our first competition, and luckily we did really well in it because one of the problems we had, we were able to fix it. But honestly, we got really lucky because our robot, it wasn't working. In some of the rounds, it stopped working because a wire would disconnect while the elevator moved in one of the signal wires. So it's kind of pure. It happens occasionally.
So another thing, another tendency that I've seen in my teams is a lot of the wiring comes in pre-built lengths. And if you really want to button down your wiring, you need to get into doing custom cable lengths for each extension mechanism. So you don't have extra that's hanging out and could possibly get tangled in things. But that does require spending some time on, splicing usually, or doing your own end connections. I tend to recommend splicing somewhere in the middle if you have like a standard connector that you use, and joining multiple cables or extending them with something in between, as opposed to trying to crimp your own end connectors. That tends to be more difficult and take more patience than I see many of my students have. So take that for what it is. Yeah.
Hey, Pat, are there NEC, well, I guess here in the United States, I think it's the National Electric Code. Do they have guidelines for wire gauges versus how much current?
Definitely.
Yeah.
So the Canadian Electrical Code, or I'm in Ontario, the Ontario Electrical Code, recently switched over to the IEEE tables as far as AC and DC amperage for wire sizes.
Yep.
Except for number 10 and smaller, where they continue to use the old Canadian Electrical Code values, which supersede the IEEE. So it's like.
Oh, sorry. I thought you'd finished, Pat. Sorry.
No, that's fine. No, I'm good.
Sunrut, do you feel that the problem is not knowing how to diagnose which wires are faulty, or is it the mechanical robustness of the wires that you have in place that's your major problem?
I think the major problem currently, we've been getting better at identifying the wires, but the major problem is just the robustness of it, where our wires disconnect too easily. And the idea is that there will always be problems with having to figure out where some wire is not working. But I feel like there should be a way to fix the mechanical aspect of our wires repeatedly disconnecting.
Yeah, every time you have somewhere near where the connection is, you need to have a hard point, a hard place to attach the cable with, so that if it gets tugged on, that's going to be your that's basically where the strain relief starts. So you don't, so it doesn't follow down into the connector itself, because that's the weakest part of the link usually.
Like a zip tie or.
Zip ties, we use zip ties all the time. Yep.
Okay.
To like a a hole in a piece of aluminum, or whatever your structure is, that kind of a thing. Sometimes to a bolt that's sticking out, and sometimes like wrapping it around that bolt, or it's like you can use multiple zip ties as well, to just make sure that it's not going to get yanked. Yeah, that definitely helps.
Okay.
Are you guys finding that you get broken wires from, something being bent back and forth, or up in, some motion that continually bends the wire at the same point?
I think that does happen, yes, especially for CAN wire. The 16 gauge wire is a little weak.
Mm-hmm.
Yeah.
Yeah.
I think it would be better, especially I didn't have any current photos because our bots changed a lot after the competition. We have to repair some stuff, but I think it would be better. I'll join the Discord and actually get some better photos of the robot to be able to send, and it would be easier to troubleshoot it. But I think the main main thing was just once I get those photos, I just need to understand how to better improve our wire structure, so that we don't have those mechanical issues with them.
Yeah, definitely avoid hard bends in any wiring.
Okay.
There's a minimum radius for any given wire, and I would say that make it bigger than like the radius of a quarter at minimum.
Okay. Here, so if I want to join the Discord, just to be sure, I emailed that president@dprg.org.
Yeah, that's me, and I'll send you back an invitation to the Discord.
Okay. I'll probably have to head out now, but I'll send pictures this week of the actual robot's mechanism. It'll be easier to troubleshoot it. I don't have any good photos of it currently, so it's a little difficult to troubleshoot. But the main thing is I just want to find a place where I can ask some questions, since we don't have a mentor to actually figure things out.
Well, good for you. I applaud your what's the word? Not ingenuity.
Initiative.
Enterprising approach of going out and finding other people who do robotics, and certainly Kareem Ponderson-Moore is among the most expert of the experts in this rough and tumble. It's got to work fast and reliably in a competition kind of environment. So he has like really good advice to give.
Thank you all for having me. And
all right, thanks for joining us, Sunrut.
thank you. Have a good night, everyone.
Good night.
Good night.
Thank you for your help.
Let's see, where were we? So we were debugging, or Pat was debugging his stuff.
Python code.
But we were at a higher level. We were kind of in open mic. We can either. I've got some other things I ran across. I don't know if other people have some other things that they ran across that they'd be interested in sharing.
Well, how's Robbie doing? I haven't worked on the head yet. I'm want to work on it this week.
Oh,
what's the time frame for this, Robbie?
So it needs to be done by the April RBNV exhibit, which is like I think April 23rd or something like that.
26. Yep.
I can still procrastinate. Okay. Yeah.
Okay. But earlier is better.
Right.
I got the wires fixed up, replaced the flaky USB cable, put in a longer white extension cable to the laptop, and Mark and I made a wiring diagram of it, and that came out, I think, will be useful to us.
Yep.
And I've got various other construction works in progress to help, the bits. So why don't I just share what I think we're all doing on this, and we can see if that makes sense. Let's see, how do I do that from here? Let's see. There we go. Present. Window. Robbie to do. So, oh yeah, I've got a suitable thing for going over the hole in the suitcase where the neck protrudes. Oh, Mark, how's that right wrist coming along with its wobbling?
It's coming along.
Okay.
I was trying to figure out why it's in like 1,000 pieces like it was designed in like 6 pieces, I think. Like these are separate, and these are 2 separate, and then the washers are separate, and then the outer bit is separate. And I'm still trying to figure out why it did it, but I'm not sure. But I remodeled it and I printed it in like one solid piece.
Oh.
And then that's like, it's rigid now. It's like it's not going anywhere. So
Okay.
I ordered some white filament and that came today. So I need to reprint this in white, unless we want one grey hand, which I don't think we do. But yeah,
I don't think so.
like C3PO with a red leg. No, not quite right.
Spare parts, maybe.
Yeah.
Okay. Well, cool.
So yeah, I'll get that printed up, and then the rest is okay. Pretty solid. So
I glued the other hand because it had some cracking going on, so hopefully that's taken care of.
Well, I can print 2. You want to print 2 hands?
Sure.
I'll have a spare.
I guess so. You know, the hand that I've got here is got that funky kind of almost hexagonal or pentagonal end on the flexible tube that twists it. But I guess if you made 2 complete assemblies, that would.
You mean this part at the end? This?
I can't.
It's like a.
Oh yeah.
Disc thing. Yeah.
Yeah.
I can print some more of those.
Yeah, if you made 2 of them, then we could just like have 2 new ones.
Yep.
Okay.
Alrighty.
Let's see, Mike, you've got the getting the camera mount working.
Yeah, I haven't thought about it much, but I assume we want it on the front of the face.
There's a hole, if you look in the head, there's a hole somewhere in the vicinity of the eye. If you're looking behind it, where you can see a camera is intended to look through.
Oh, okay. Yeah, so
we just need some kind of a camera and a mount to look through it.
so if I look inside of here, well, I see a hole for the camera. So yeah, I didn't know how I was supposed to mount. So
yeah, well, I don't think I couldn't see a way of mounting it, so I think that needs to be invented.
Yeah, looks like it was super hot glued on there or something before.
Yeah.
Yeah,
I believe that.
I feel something like hot glue on that board. Or
yeah.
Okay. And Mark was talking about a different camera. What's the feeling about that? Like a
well, yeah, no, I had what are these? Some ESP32 rovers with built-in cameras. Oops, yes. But I'm still having trouble getting that running. But I did pick up an ESPI, which is kind of cool. I kind of like that so far.
Because right now we got this camera here with the USB connector on it.
Mm-hmm.
And the USB cable goes up into the head and then down to the USB switch in the body, and then out to a external external notebook. So
yep.
So if you put a camera like that, we could plug it into the USB to get the signal out.
Yeah.
Yeah. Okay. As you can see here, the front of the camera here. So okay.
Mm-hmm.
I got a little bit more information. That's good. Thanks.
Yeah.
Definitely on the would like to have list. It's not.
Yeah. You know, I think restoration is a priority over making better. And it used to use that camera, and if it was hot glued in, then hey, you know, I don't see it matters.
What did it use the camera for?
Yeah.
It had face recognition, and it would pan and tilt the head to look at a face that it found.
Okay.
And then then there'd be some hidden speakers that would like say something. I had painting the shoulder. Actually, my wife will paint the shoulder and repaint because repaint the corners because the corner rounds.
Yeah, they've seen better days.
They look kind of rough.
Yeah.
And I got some new quarter round because I had skin for the back, put a skin on the back.
Like these quarter rounds, right?
Yeah.
Yeah. Oh, you have that?
Well, it's part of the head. It's part of the head.
Oh,
it belongs on the head.
Okay. All right. Because there's a missing piece of that from the body, from the back. So I went and got some at Lowe's today, and I'll cut it to the right length and secure it to the face. And then I need to get with Doug, and he said he's got some of that white corrugated plastic that's used for the skin. So I'll get with him, and I got some Velcro dots. So I'll get it so he's got a back skin.
Sounds
So
good.
is there a policy that you're using that like the Star Trek ethic or aesthetic versus the Star Wars, right? The clean lines, white gleaming versus beat up and run down.
Yeah.
Because one of those is a lot easier to maintain, and it ain't Star Trek.
What's a lot easier to maintain, Cream?
The Star Wars aesthetic of things being all beat up and weathered.
Well, I got to confess, it does look a little beat up at the moment in terms of like the quarter rounds are all kind of grubby looking and.
Yeah, I mean, you can double down on that and make it part of the strategy, so you don't have to worry about the look of it so much. It's a real world, been there, done that kind of robot, as opposed to
Patina,
just off a factory floor, right?
Yeah.
Yeah.
They'll have a little patina, a little life experience there.
Yeah, it might give you a little more freedom that way.
This is the front of the robot here, the eyes.
Yep.
And this is the back side of it.
Is that duct tape?
You can see it has duct tape and that's where the camera goes like that.
Yep.
So this needs a little TLC, I think, but it's basically operational.
Yeah.
So, those little strips here are the LEDs. I think
this is Dave Ackley. I'm responsible for that kludge from way back when, I don't know, 5 years ago or something.
Almost
Looks like it's held its own there, It's still in place.
So it's quite functional, but all the quarter rounds on the head are just they got glued. They were glued together, and all the glue is just disintegrated. So I gotta just reattach everything together, the frame, like like you can see right there.
Oh.
Yeah. So
hot glue never fails.
Never does. Yep.
I don't know if that's hot glue or super glue.
Fades away. Yeah.
It feels like it was super glue, but I have no idea.
I'm thinking construction adhesive.
I was thinking of screws.
Oh, yeah, that'd be nice, except quarter round doesn't have much meat to get a screw into.
Right. Yeah, because if I look at these, and then the corner pieces of the head were 3D printed. And then the quarter rounds were basically hot glued or super glued or something to it. Oops, something fell off. So, yeah, it needs some work.
Yeah. Yeah. Little bit of TLC, as you say. But not an undue amount, and I feel, and we should be able to have a good showable robot.
Yep.
Cool. So that's where Robbie's at. What else do we have?
Yeah.
I came across a couple of interesting information over the week. So one of them was the ROSmetrics report, and it just gives you an idea of the scale that ROS has achieved. So this was a 2023 to 2024 comparison. Total packages downloaded went up 1.5%, 47 million packages downloaded, of which 25 million, 31 million were ROS 2 packages in 2024, as of October 2024. The number of contributors on the ROS 2 GitHub stayed as roughly steady at about 250, up about 3%, about 10,000 pull requests. So that gives you a sense for the scale of what's going on in ROS. 3 million gazebo packages downloaded. Of which the majority were the modern gazebo. ROS discourse. Oh, I don't know. You guys probably can't see this because it's like probably way too small. Sorry about that.
There you go. That's better.
So ROS discourse is is kind of like their version of Discord, and about similar number of annual topics, about 1,000 topics, about 4,000 posts, about 2,500 new users in the year. So it's significant. 1,250 companies using ROS. So anyway, I thought that was interesting data. The other thing that I thought would be interesting to share that I came across is I came across it in a robot news feed. It's Le Robot, and Le Robot, I don't really understand it very well, but it seems that so I came across two commercial ROS for hobbyists kinds of organizations, and one of this is Hugging Face, and their emphasis seems to be on AI for robotics. So they say they aim to provide models, data sets, and tools for real-world robotics in PyTorch to lower the barrier to entry to robotics. and they have state-of-the-art approaches that transfer to the real world with a focus on imitation learning and reinforcement learning. And they already have some pre-trained models. And to be honest, I don't really understand what all this means, other than that it's AI for teaching robots to do things. So that was interesting. And then the other thing I came across was Maker's Pet, which they have a video series on building an Arduino self-driving robot that uses ROS2, and there are 5 videos in the series. And in a nutshell, I sort of like skimmed the videos to have a quick look at what they're about, and what they really are is the same architecture as Lino Robot. So you guys know I'm working with Lino Robot, which runs micro-ROS on an ESP32, talking over Wi-Fi to my laptop running ROS2, and they're doing the same thing. They've got an ESP32 there on the board there. As far as I can tell, I looked at their code, and as far as I can tell, it's not a derivative of micro-ROS. It seems to be its own thing. But they've got the robot sends the LiDAR data up to your laptop, which runs the ROS navigation stack, and sends motion commands back down to the robot. And they've got a video of it. Navigator. See that? So they've got these little robots that they sell on Makers. And so it runs around and does really what I'm trying to do, I think, some ways, and what the Lino Robot tries to do. Anyway, I thought that was pretty interesting. So anyway, that's all I had.
Those are pretty neat.
Yeah, and he looks like he's done a real nice job of packaging it all into Docker instances. So he runs Dockers all over the place, and you don't have to worry about, or runs Python in virtual environments. And so, he's dodging a lot of the problems that you run into with version mismatches and stuff. And looked like he'd done a real clean job of it, and was pretty much hiding a lot of the complexity of micro-ROS and topics and all this kind of stuff, and just giving you simple instructions on how to launch a Docker, and the Docker launches RViz, and then he tells you click here and point the arrow in whatever direction you want it to go in, and gives you kind of a turnkey solution. So I was like pretty impressed.
Yeah, today I was running ROS on the robot, and it was sending the point cloud data to RViz on the computer. So, but I'm anticipating I'm just going to run everything on the robot so when computer's not needed, it's just for debugging and show and tell. hopefully the Pi 4 is good enough. It seemed good enough yesterday or last year. But sometimes that Wi-Fi interface just bogs down for some reason. That's my concern is poor Wi-Fi.
Yeah. Yep.
Because even sending stuff to the laptop, it sort of is spurty. Like the topics that are running on the robot, when I show the topics on the laptop, there's just not as consistent of a flow as I would hope for.
Mm-hmm. Yeah, it's going to be interesting to see how all this works or doesn't.
Mm-hmm. Need a lot of error checking. And what do you do when your packets interrupt for half a second?
Yeah, absolutely. So anyway, well, anyone else got anything that they discovered over the week?
Hello?
I have my my rotator, my wall art rotator. So you can sort of see it on the wall here, rotating. And it's been rotating for a couple of weeks now. And so this new motor I have works really good. And on a 5,000 milliamp hour battery, it rotates for not quite 2 days, but I think about 2 days. And so I'm going to tell the artist that if he wants to rotate it for a week or so, get a 25,000 milliwatt hour, which are only like 20 something bucks. So
what's the point of the rotating thing?
This artist wants to have rotating art for his art show.
Oh.
So I'm building a prototype, and it's like, okay, well, if this seems to do what you want and everything, and then you want to start selling them, then I'll have to. That's a different problem. Making the prototype's fun. Going into business is not fun. So
right. Cool. And Fernando, you said you're about to speak up with something.
Yeah, so yesterday I was trying to install Clipper for my 3D printer, but then I ran into an issue afterwards when I was trying to flash the firmware onto the printer's main board. I think I bricked it, or at least I can't get it to start up again. I might have done it in the wrong spot because I was doing it in it's an Ender 3 S1 Pro, and I was what's it called, using the SD card that's next to the USB port, but then I found out that there is a slot for a micro SD card inside of on the board for the LCD screen that it has. So I'm not sure if I was supposed to use that one. And I could have also done something when configuring the files that actually get flashed, but I'm not entirely sure, and I've been trying to figure that out. So I was just wondering if anyone had either experience with flashing updated firmware, stock from Ender onto an Ender 3, from Creality onto an Ender 3, or if anyone's had experience with Clipper or something similar to that.
I run Clipper on my 3D printer, but I have a
Oops, Mike froze.
Yep.
I have a.
I know the answer. It's
just at the crucial moment. Doesn't it always happen?
yeah. I haven't installed Clipper, but I have updated my firmware on my printer, and I have an Ender 3. I've always used that little micro slot that's in the front, not the one that's in the display. It's always been in the machine itself.
Okay, so it might have been some kind of issue with the actual file that I was configuring.
Could be. Yep. I'll try downloading just one straight from Creality and try that.
Okay.
But they're hard to break, so yeah, you should be okay.
Yeah, I think it's just the wrong firmware on this. So once I find out how to get the just stock one, it should work again.
Yeah. Hey, Mike's back.
You cut out at the critical moment, Mike.
My PC went black.
It's done for the day.
The black screen of death, is that worse than the blue screen of death?
I don't know. It's a Linux computer too, so I don't know what that means.
So you were about to say something about Clipper and
Oh yeah. Before my computer blitzed out. I use Clipper on my printer, but it's an old printer, and I just used the Pi 3 board with an LCD screen, and then plugged in the USB cable from the printer board into that. I didn't try to load it into the processor inside of the machine, and I don't know anything about Enders. So. But it works really well when it's working, and mine's been working for 12 or more years, and I'm afraid to update it. Yeah.
I was wondering, when you were doing the config for the actual for the files for the printer, did you have to do something for the LCD screen to work? Because I know you have to change stuff depending on the board that's on your printer. Although maybe you didn't have to do this part since it's running completely off of the Pi. I'm not sure.
Right. I didn't change any firmware inside the printer.
Okay.
The printer has its own LCD, and then I have another one for Clipper. So
okay.
I did it a completely different way. So
okay. Thank you.
And it was an 8-bit processor anyway. So and it's still an 8-bit processor.
Yeah. Clipper's like an improved firmware for your printer. It makes it print faster.
Oh, faster?
No. Well, nicer. It's more efficient from what I hear. I haven't tried it, but I need to try it. So.
It spools out the data and it processes the data from the STL file. But so. But I use it for remote control, so I don't have a cable. I just work on my CAD files, and my everything works on in the what do you call it, the one that builds the file on the computer, and I just remote log in into the printer's Clipper, or I guess Octo. It's Octo. Oh, okay. I'm sorry. I got it all put together. I used Octoprint, and I installed Clipper into Octoprint, and then from there I plugged in the just the existing board, the cable for the board, so that sends the servo commands down to the board. The board right now is just doing servo commands. It's not really doing anything smart.
So I'm afraid you're at the cutting edge here, Fernando.
Yeah. So I think one question that Fernando has, which I can't answer, is: does anybody know about Ender and their boards and their LCD screen? Because I know nothing about that particular machine.
Yeah, I have an Ender 3, but I couldn't answer the questions. I don't know how to use it. I know how to take it apart, but that's about it.
Me too. Got an Ender 3 V2, and just works. I just plug the SD card into it, and it sets off printing, and I go away and lie down, sleep for the night, and it's done when I get up in the morning.
Yep.
All right. Well, thank you all for the advice. I'm gonna try to get stock firmware on it to see if it works.
Good luck, Fernando.
Thank you all.
Okay. Anything else? Going once, going twice, going 3 times. All right. Should we call it a night? Good night, everyone.
Night.
Thanks for the help.
Good luck, Pat.
And my computer booted up.